Hello, this is Dr. Mears. Today we're going to be deciding if a relation is a function or not a function. We're going to be looking at 4 different representations: ordered pairs, table, equation, and graph. So first are ordered pairs. So we have to decide which is a function and which is not. So the first thing that we have to remember is for each function, we can only have an input paired with exactly one output. I'm sorry, I couldn't really see. Input has to have exactly one output. Remember, our input is our x and our output is y. So here, for these ordered pairs, I have 0, -1. So the input is x and the output is y. So this 0 is now paired with -1. It cannot be paired with any other number. So let's see. This input is 1, this input is 2, and this input is 3. So there's no other zeros there, so I'm all set. This input is 1, so let me make sure there's no other 1s here. And so this 1 is paired with 2, so we're all set. This input is 2. Again, there's no other 2 inputs, so this 2 is fine. And this -4, there's no other inputs of -4, so we're all set. So yes, this is a function, and to justify my reasoning, I'm going to say each input is paired with one and only one output. You could also say exactly one, either one you want. I'm using a couple different words here just so that you can make your vocabulary a little bit more extensive. Okay, let's look at this second one. So right here, I have an input of 0 and an output of -1. So let's make sure there's no other inputs of 0. Nope, I see none. So that's fine. Okay. This one has an input of 1, but it has an output of 2. Okay, so it always has to be paired with the 2. All right, I'm putting 1 in again here. See this? This is the x. I'm putting 1 in again. What am I getting out? I'm getting out 4. That is not right because this one was paired with the 2. It always has to be paired with the 2 from now on. Here, it's not. So this is not a function. And the reason is the input of 1 has 2 outputs, which are 2 and 4. This cannot happen. It can only have 1. It can either have 2 or 4. We saw the 2 first, so that's what I was looking for. Okay, that was ordered pairs. Let's do a table. Here you have a table. So let's look over here. This might be a little bit easier if you weren't understanding that ordered pairs. Remember, this is the input and this is the output. So what we're making sure is when we go down, we see that this 0 is paired with this -1. So if there's any other zeros here, it has to have a -1. There's no other zeros. Okay, this 1 is paired with 2. I see no other 1s, that's fine. 2 is paired with -3, and -4 is paired with -5. So like this one above here, yes, it is a function. Each input is paired with, and if you want to write exactly 1 output, you can for that. And just another way of writing the same thing. Yes, each input is paired with exactly 1 output. And if you wanted to describe these inputs, 0, 1, 2, and -4, you can. And each one, -1, 2, -3, and 5, respectively, you can. All right, let's look at the second one. So here we have our inputs, and here we have our outputs. So remember, if I put in a 0, I'm going to expect to get -1. And there's no other zeros. I put in a 1, I am expecting to get a 2. So look what happens here. I put the 1 in again, just to test it out for fun. Guess what I get? A 4. I cannot have that. This needs to be a 2. If it's a 4, that means this is not a function because the input of 1 has 2 outputs, 2 and 4. That cannot happen. So because I put my 1 in again and I got out a different answer, this makes it not a function. The input of 1, right here, has 2 outputs, and they're different, 2 and 4. Okay, they can't be different. So this one was exactly like this one, except it was a different representation. We have ordered pairs here, and we have tables here. Okay, let's look at two other representations. I'm just going to flip this over because it was on one sheet. So function or not a function. We have an equation, and underneath you'll see your coordinate plane. And we can draw that line in together. All right, let's first test a function. So what we want to test is we want to put an input. Remember, the x is your input. So let's try an input out. Let's try the number, let's see, 6. Okay, so if we put 6 in, what we do is we're really just going to substitute 6 in, plus 5. So now we're going to multiply 1/2 times 6, which is going to give you 3, plus 5, which is 8. As you can see, I got one answer out, the number 8. So yes, this is a function. Each input has exactly one output. And you can see the input of 6 has an output of 8. Ran out of room there, sorry. The input of 6 has the output of 8. So it will always be 8. So if I put 6 back in again, let's pretend I'm putting 6 back in. Well, 1/2 of 6 is 3, plus 5 is 8. It'll always be 8 if I always put the 6 in. Let's look at this one. Y equals the square root of x. We have to determine what number we can take the square root of. So let's do an input. Let's do an input of 4. Okay, input of 4. Oops, sorry. So what does that look like? Y equals the square root of 4. So we have to ask ourselves, what two numbers, when multiplied, give you 4? Well, let's see. I'm going to do a little math up here. Let's see. 2 times 2 gives me 4. No, that's one way. So y equals 2. Or there is another way. When you think about it, -2 times -2 gives you a positive 4. So y could either be +2 or -2. Sorry, the lights just went out. So what happens is we have two different answers for the same input. We can't have two different answers. We cannot have two different outputs for one input. So this is not a function. The input has two different outputs. And you can say input 4, output 2, or -2, okay? So we can't have both. We can only have one. That's why that's not a function. Okay, the next one, I'm actually going to erase my little line down here. We're just going to draw a line in together. Okay, so next one are coordinate planes. So I just drew a line in here. You can draw the line anywhere you want. I just drew it up there. Remember, this is x and this is y. We're going to use what's called the vertical line test to determine if this is in fact a function. What a vertical line test, it makes sure that no points are on top of each other. No points look like this. They're like a semicolon. They're not on top of each other. We cannot have 2 points on top. We can't even have 3 points. That cannot happen. So what the vertical line test does is you pretend your pencil is a line, and you're going to scan your document to make sure that a situation like this doesn't happen. So if your vertical line or your pencil hits 1, 2, 3, more than 1 point at a time, it's not a function. So let's look at this line up here. How many points is it hitting? Just one on the line. Just one, just one, just one, as I'm scanning over the document. So it's just hitting this line once. So because we don't have that situation, this is a function. Passes the vertical line test. Only hits 1 point at a time. Okay, let's look at something different. Let's draw a circle. Okay. Try your best to draw a nice circle. Here's our input, here's our output. Now, if we're going to do the vertical line test, remember we're going to do a vertical line and we're going to scan this document. What happens? If I have a vertical line and I'm scanning my circle, what happens here and here? We have 2 points on top of each other. We have this pencil hitting 2 points, which means we have 2 different outputs for one input. So because this does not pass the line test, it is not a function. Does not pass vertical line test. Vertical line hits 2 points at once. That cannot happen, ever. So this imaginary vertical line here hits 2 points at once. Can't happen. It didn't here. It just went all the way through, only hitting 1 point at a time. Not so much here. So this has been different representations determining if it passes or doesn't pass our function test. I hope this helps. Let's practice and then move on. Thank you.